good morning. All right, welcome to DevCamp. I am Bryan Costanich. I am co-founder and CEO of Wildness Labs, and I am super excited to be here. I think this is an incredibly dynamic time in the history of humanity's technological progress, and it's been really fun to be a part of it. The last company that I helped build was Xamarin, and Xamarin brought .NET to the mobile space, and now with Wildness Labs, we're bringing .NET to IoT, which is incredibly exciting. So with that, welcome to DevCamp 2020. This is going to be a lot of fun. DevCamp is going to be a journey of the physical. Unlike a lot of software conferences, traditional software conferences, we're actually going to talk about some physical things, and we're going to talk about hardware. We're going to talk about building enclosures and other things. We've got a lot of really great sessions lined up for you today. After this, we're gonna go through getting started with Meadow OS and Meadow Foundation. So if you picked up a hack kit for the conference, you'll definitely want to tune in for this. And if you're new to Meadow, if you're new to Meadow Foundation, all that, this is gonna be this is a session for you. It'll give you a good overview of what's going on and get you kind of immersed in the world of IoT through Meadow. We're also going to have a couple of awesome sessions from great folks around building 3D printable project enclosures. Jorge Ramirez, our developer advocate, is going to show us how to do it in Fusion 360. And Frank Kruger, the well-known .NET friend and guru, is going to show us how to do it in OpenJS CAD. So whatever workflow those works for you, whatever you want to try, that's you got your choice there, a little freedom of choice. And Bryn Lewis, hailing all the way from New Zealand, is going to give us a taxonomy of wireless technologies and tell you how you can hack them and how you can integrate with a lot of pieces of IoT and other things that are actually out there right now that have wireless in them, and how you can connect to them via Meadow. So that is an awesome talk. I can't wait for you folks to see that one. And then I'm going to be giving a talk on creating a custom PCB. We're going to churn a custom Meadow wing. That's a PCB that plugs into the Meadow board. And this is going to monitor the health and well-being of my beehive. So we're creating a smart hive. And I'm really excited about that because PCB creation is a little bit intimidating, but it turns out that it's incredibly easy. So that's going to be fun. All talks will be recorded, so you don't have to feel like you need to choose a track this afternoon. Don't worry. We're going to record them and post them for later perusal. But first, before we get into those sessions, I want to talk about technology because I think that our lives are about to change radically. In just a few years, the number of non-mobile connected devices in the world will be massive. There will be 10 for every human on the planet, and that is going to drive a radical shift in computing. In my lifetime, I've seen in terms of our technological progress, I've seen massive epochs. I've seen desktop apps come out and be a thing, and then web apps. The web launched, and the internet changed us forever. And web apps were huge, and then mobile hit, and of course mobile ate everything. And the next epoch that we're in transition to right now is one of hardware, one of IoT, of connected embedded systems. And I think that will prove to be really, really interesting. We have gone from this idea, Bill Gates' vision back in the 70s was to put a computer on every desk and in every home. And now we're at a place where we can put a computer literally in everything, everywhere. And it's an interesting epoch because unlike the mobile revolution, which gave us such a beautiful hero experience, I remember 13 years ago, Steve Jobs stood on stage and he showed us the iPhone, and it was this beautiful piece of glass, and it was cinematic, and we can interact with it, and it put a supercomputer in our pocket, and it was a quintessential hero experience. But unlike that epoch and epochs before, the embedded revolution won't have a hero experience for that. It will be more of an incremental change as lots of little things go in around us and change things in a much more gradual way. So while the revolution is coming or is here, you might argue, we might also barely notice. And that's really interesting, but it will spur a radical shift in culture and our relationship to the world, just like mobile did. I can't even imagine navigating someplace now without Google Maps, and IoT will usher in that kind of change in our lives as well, because the interactive world is coming. And this is really interesting because with IoT, not only will we be able to put sensors and things everywhere and get all sorts of interesting data coming at us from the things that are going on around us in the world, but it's a two-way street. We'll also begin to be able to control those things and have a tremendous amount of power in the world, and the way that we interact with the world will shift quite drastically because of it. The promise of IoT, of embedded, is a new era of efficiency and productivity. With embedded hardware and embedded computing, we're going to start seeing a lot of industrial processes streamlining, and we're going to see the next generation of automation, and we're going to start to see things like much bigger crop yields and things like that for much less effort. This is really going to be a game changer in things like ag tech and industrial automation. This is a place where sensors and things like that can prevent downtime by giving us failure sensing and tell us when it's time for preventative maintenance. And it's also, in terms of like goods and asset tracking, is a complete game changer, because today tens of millions of dollars of expendables are lost in port, for instance. But there might be a shipment of bananas coming into a container, coming into a port in a container, and it gets misplaced and the bananas go bad. We lose stuff like that all the time. And now with IoT, you could walk up to a container, scan a QR code, get exactly the information, the manifest inside it. GPS could tell us where it is in port, and of course, we would know all the temperature and climate and other sensor information about what's going on in there, so we can actually save those and be much better about the transportation and tracking and whatnot. And of course, everyone talks about the environment and the things that we can do with data and monitoring in the environment and whatnot. So there's a lot of really interesting things that IoT can do. And in fact, IoT is already here. It's already happening. Everyone knows about Nest. It was, the game changer for home thermostats. But there's all kinds of really interesting IoT out there. This orange bar in the center there, that's a temperature and humidity sensor that you can toss into a grain silo, and it will give you real-time information about the temperature and the humidity, and can prevent tens of millions of dollars in loss due to grain spillage alone every year. I mean, this is such a simple thing that can provide such a radical value. And GasZen there on the right, that is a smart sensor that goes on your natural gas tank or your propane tank at home, and you never run out of gas, because when it gets low, it automatically calls to your local gas company, and they come out and fill it up. And of course, smart meters are on their way. Some of them are here. We actually have customers building smart meters on Meadow, and smart meters will radically transform the grid. It's a big part in the modernization of the modern electrical grid, because we've gone from this consumer-client relationship where you have big power generation plants and then lots of consumers, to a place in which we have a really distributed grid in which these consumers may also be micro power generators. You might have solar, you might have other things, and those things have to be, there needs to be load balancing and reporting and things around that. And smart meters make a huge difference there. And of course, this last example that I chose was kind of a random one, but it shows It's Lime Scooter, and it's an interesting one because you don't think of it as IoT, but it's in fact just a classic IoT use case. You got GPS tracking, you got Bluetooth integration, you can control it with your phone, you got billing and stuff all automatic, and the motors on that thing won't even turn on until you've authenticated and whatnot. This is like classic IoT, and so IoT is really already happening all around us. And because of that, there's today a huge developer opportunity. Nearly every company out there is trying to build, nearly every major company out there is trying to build IoT. And in fact, they're spending more on IoT today than mobile. And the spend is actually 5 times bigger than both big data and AI combined, which is sort of mind-blowing that the revolution, like I said, is already here. And so while a lot of us spent a good portion of the last decade building mobile apps, it's a good bet that a lot of us are going to spend the next decade building embedded apps. In fact, today, there's a greater demand for embedded developers than there ever has been. So there's no time better than right now to upskill and learn hardware, especially all the other stuff that's going on right now. I mean, anytime there's an epoch switch over, anytime there's a new part of the revolution and computing revolution, then those are the skills that are really in demand. And today, hardware is the thing. And so I want to take a step back a little bit and take a look at understanding, what is this embedded hardware thing? Let me get my head around that. Because it's important to understand that the revolution is brought to you by microcontrollers, also known as MCUs. And these tiny little things are really powering this change. In fact, they are soon to be the dominant form of computing on the planet. But what the heck is a microcontroller, right? Well, in its simplest, a microcontroller is, you can think of it as a computer on a single chip. But it's more than that. It's more than just a little computer. It's also built to control hardware. And it was built to control hardware from day one. The first microcontroller was the Intel 4004, and it came out in 1971. And it was the first time that all of the components necessary for computing, to process as a computer, was put on a single IC. But they didn't stop there. They actually added hardware I/O so it could integrate with sensors and things like that. And even back then, a microcontroller, it's important to understand that a microcontroller is different than other classes of computing that are available today. It's not a CPU, it's not an app processor. And in fact, if you do look at the taxonomy of computing, if you look at these classes of computing, you see that microcontrollers are what powers the Meadow board and what powers Arduino and Particle. They're not app processors, which are what powers Raspberry Pi or Azure Sphere, and there's a radical difference between these two classes of computing. First of all, microcontrollers are everywhere. There are trillions of them in existence. In fact, last year, over 30 billion of them were shipped. And they are in everything around us. My little remote control presenter thing, clicker, magic thing with a little display and buttons, that's powered by a microcontroller. Every appliance in your house has microcontrollers. Every electronic toy is powered by microcontrollers, and your car has piles of them. But one of the most distinguishing characteristics of a microcontroller is that they don't run a full OS. So if you're looking at a chip and it runs Linux, that is not a microcontroller. Microcontrollers run micro RTOSes, real-time operating systems, in which their footprint is measured in kilobytes rather than megabytes. There's no concept of multiple users. There's no multiple app paradigm. Basically, there's just enough operating system to service a single app and the hardware that it controls. And that is a major distinguishing factor about microcontrollers. and all of these things combined make them really, really interesting because they're also incredibly low energy. A microcontroller uses fractional thousandths of the power, consumes fractional thousandths of the power of of like an app processor that you would find in a single board computer like a Raspberry Pi, which means microcontrollers can be embedded anywhere, and you can run them off of coin cell batteries or batteries. You can run them off of solar power over Ethernet. You can even run them off of passive energy harvesting. They consume that little power. So for low power designs, you absolutely need microcontrollers. They're also commodity cheap. So you can embed microcontrollers for dollars as opposed to tens of dollars that you would find in the total cost of app processors and whatnot. And it's interesting because you might ask yourself, well, why now? Why are microcontrollers so interesting now when the Intel 4004 came out 50 years ago? Well, it turns out the microcontrollers of today are very, very different than the microcontrollers of yesterday. And they are different because of the mobile revolution. The mobile revolution gave us chips, sensors, and batteries, etc., other peripherals that are faster, cheaper, smaller, and longer lasting than anything that came before it. And so mobile really made modern embedded computing possible. If it weren't for mobile, we wouldn't be having this conversation today. In fact, if you look at the microcontroller in our flagship developer board in the Meadow F7, that F7 chip has the processing power of a Pentium. But not only is it that powerful, but it also has a whole host of really interesting hardware specific features. And I mean digital I/O, analog I/O, all of the protocol support that you would need for peripherals and sensors that you can imagine, PWM, piles of these things. And there's all sorts of other goodies that you'll find in there as well. Graphics acceleration, JPEG encoding, hardware encryption, trusted computing features, and more. This thing is just jammed packed with really, really interesting hardware stuff. However, despite the fact that microcontroller is so powerful, despite the fact that hardware has changed so much and so drastically in the last few years, developing for microcontrollers today is really still stuck in the 80s. And this is and one of the things that we've actually learned in building Wilderness Labs, one of the biggest takeaways that have really sort of surprised me over the last few years, is that most of the hardware that you build when you're building IoT solutions, most of the hardware involved in that is pretty easy. And in fact, it's a lot of fun. I'm having a blast building hardware. But the thing that's hard is building the software, building the apps. Like I said, it hasn't really changed since the 80s. If you're an embedded developer today, it's a good chance that you spend 98% of your time writing code in C or C++. You fight with make files, you're writing plumbing code all the time, you're writing drivers, you're writing code that you really shouldn't have to write anymore in modern app development. You're doing things that your peers in web and mobile development and desktop app development are not having to do anymore because it's really still very rudimentary. And what's more is that you have to build twice, because the way that folks build IoT today is that first they'll prototype, they'll go early and initial prototypes on like a single board computer, something that has an up-level platform. You might grab a Raspberry Pi and load .NET on it or Mono, and you build on that. And then what happens is that, okay, so you need to go from your initial prototype to your next version of prototype, or you want to go to production. You have to rewrite it for embedded development, which means, okay, throw all that code away. Now let's rewrite it in C++ and make it, deep down into the metal. And it is a headache. And so all this means that if you're writing embedded apps today, not only does it take 10 times the effort to write the software as it should, as it would to write a web or mobile app, but it also means that you have to multiply the time and cost by 2 after that, because you have to build it twice. It's absolutely insanity. So when we started Wilderness Labs, I asked myself, and we talked about this, and we said, what would it take to write IoT apps as fast and easy as mobile or web apps? What would it take to modernize microcontroller development? And after years of cranking, we have Meadow. Meadow is our answer to that. And let me explain. First of all, Meadow runs full .NET apps on microcontrollers. It is literally the only platform for microcontrollers in existence that is both modern and professional. There's nothing else out there like it. And we've solved the hard part of hardware for you. We have embeddable dev kits that you can build on today that have all the hardware that you need. You don't have to worry about the hard stuff like high-speed signal processing and multi-layer boards and blah 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 blah. All the difficult things that go into a high-density SOM or high-density dev board. We've handled all that for you. And we built it and we've designed it in the Meadow or in the Feather form factor, which means that it conforms to an industry standard and has everything that you need to build hardware, including battery charger. The dev kit has Wi-Fi, Bluetooth, piles of I/O, blah blah blah. This thing is really, really incredibly powerful and easy to use. But the upshot here is that because you're building on embedded hardware from the get-go and it's embeddable, you go from prototype to production on the same hardware and the same code. No more building twice. And we've built an additional layer. Meadow is a full stack IoT platform. And on top of Meadow OS, we've built this thing called Meadow Foundation. And Meadow Foundation makes IoT development plug and play. With Meadow Foundation, if you go to Adafruit or SparkFun and you buy sensors or modules or motors or whatever, you simply follow the instructions, follow the documentation, good documentation that we have in Meadow Foundation, plug those in, and you have a beautiful curated API that's ready to go, that's consistent, that's modern, has iObservable support, modern eventing. It's really incredible and powerful. And when you do want to go to scale, if you make a product and you want to get tens of thousands or hundreds of thousands or millions of them out in the world, we are developing SMT modules for high volume deployments or for specialized industrial scenarios, or you can license Meadow directly into your custom circuits if you have specialized circuit needs. And on the horizon, we're working on a thing called Meadow Cloud, which means that you can, when you do go out to scale, you can manage all your devices out in the field with over-the-air updates and security updates, as well as device and health monitoring. And so Meadow is really a full stack modern IoT platform. So we're really excited that you're joining us today, because we think that Meadow is really a hardware democratizer, because the solutions that were once out of reach, that were really only within reach for the most well-funded and specialized teams, are now available for every developer. Every developer can now build hardware with Meadow. Now, with all that said, Meadow is a work in progress, and I want to talk about our status and our roadmap. I want to talk about where we're at and where we're going. So first of all, Meadow is still in beta. It's not ready for production. And with that said, I really want to take a moment to thank and to appreciate big ups to our early adopters and our Kickstarter supporters and folks that have bought Meadow dev kits and hack kits and are out there today actually building products on Meadow and getting ready for this revolution, because you folks have really kept us going. You made us successful on Kickstarter, and you have been tirelessly and patiently working with beta software, providing feedback, providing important, you've been steering and driving our development, and we really love you. You've been awesome. So thank you. I can't tell you that enough. Today we launched a new website. Actually, it went out yesterday, but we're announcing today. So if you are bringing Meadow into the workplace, if you want to share this with other folks, point folks to the website. All the Meadow messaging is up there. This is actually the first time in the history of Wilderness Labs and we think that we actually have a proper website where you actually know what we're about. And so I'm really proud of this. I'm proud of the team that got this up. So go check that out. Also, a shout out to Netuino. We love you. Farewell. So long. You will always be in our hearts. For those of you that have been in the community and have worked with Netuino in the past, please go read our farewell letter to Netuino. I think that you'll appreciate it. Netuino was really set the gold standard for .NET Micro framework, and but we're really excited to move forward with the next generation of technology. So all that now aside, let's actually look at the platform. Let's look at hardware first. So our Meadow development kit is V10. So this is production ready. This thing is solid. This is an incredible piece of hardware. And we are currently validating our SMT module design. So this is a very, very tiny board, and this is for specialized industrial scenarios and whatnot. That's currently in validation. And of course, the board that it sits in to break it out, the reference development board, which is really interesting. It adds industrial Ethernet, so it has dual Ethernet jacks on there for industrial IoT scenarios. So that's actually in validation and development right now. That board that you see is actually in assembly at our local assembly shop. Really excited to bring that forward to you. And this summer, we should be releasing early versions of our Power over Ethernet version of our module, and we're looking at LTE integration sometime next year. So that's kind of a rough timeline there. We're actually going to dive into timeline a little bit deeper in a moment. Now, the software side of the stack. So as I mentioned, really the software is where things are really hard in IoT. But I'm super excited that today we are shipping beta 3.11. Now, 3.11 is the last scheduled release in our beta 3 series, and it brings a pile of upgrades and stabilization. So this, we think, is the last of the major I/O stabilizations. Within Core I/O, Beta 3.11 fixes interrupts, they're faster, better, more reliable. It also fixes the pull-up and pull-down, internal pull-up and pull-down issue in interrupts, and so interrupts should be really brick solid now. And there's also a pile of I2C improvements, both in performance and in APIs. And Beta 3.11 also comes along with a pile of Meadow Foundation improvements. We did a big overhaul of all the accelerometer and motion capture drivers, and did a big standardization so that all of the drivers in there now follow the same modern event pattern, and also have our filterable iObservable, so you can do reactive style development with them. Some big upgrades to the graphics library performance. Text display menu is in there, which is a really interesting thing. And then now we have over 100 peripheral drivers. That means that there's a good chance if you go and buy a sensor module breakout or some motor controller or something off of SparkFun, Adafruit, etc., it's a good chance that's going to work with it and have a driver already. And of course, if there isn't a driver, Meadow Foundation is also open source, so you can go and add your own driver. Now, this Beta 3.11 really wraps up a lot of the core stuff. So we're in a place now where the core I/O APIs are effectively production ready. The only outstanding, I think the only outstanding major feature there is that UART serial still missing event callbacks, which we should get fixed pretty soon. Meadow Foundation is ready to rock, super rock solid there. Very proud of that. The tooling, single touch deploy on Visual Studio for both Mac and Windows, and due to the efforts of Stuart, who is in our community, we now have Linux support. That is something that we're merging in right now, so that'll be coming soon. And of course, fantastic documentation and stuff. I'll talk about that in a moment. I want to talk about network, and I want to talk about Bluetooth. So we have an internal alpha right now of network, and all of the plumbing stuff is done for Bluetooth. We're going to dive into that in just a second. But a shout out to our incredible documentation and piles and piles of samples up on Hackster. So if you do want to get started, you can jump in there, and there is complete documentation, both conceptual and APIs, the same quality that you would expect from the same team that brought you the Xamarin Docs and Xamarin University. Good quality stuff there. Finally, to round out kind of what we've released thus far, we've actually worked a lot on performance. So Meadow is now fast enough to handle a rotary encoder, which I kind of think of as like the gold standard for real-time processing. You can run a display on it. However, there is still some opportunities here. Graphics displays, color high-res displays are still slow, but we do have more plans and lots of opportunity to speed things up. We still haven't turned on AOT, ahead of time compilation. That's coming in the near future. We actually have a proof concept of that done. It's a matter of chasing down all of the weird things in the corners and dark stuff. Now, with all that said, I know that everyone here is waiting for this. This is the big thing. This is the I in IoT, the network stack. And I want to say that we have really, really fantastic news. We are prepping Beta 4.0. So the Beta 4.0 or the Beta 4 series brings a whole bunch of stuff. First of which will be network. Network available via the Wi-Fi ESP32 coprocessor will be out soon. We are just gluing the very last pieces of API together. And in fact, you'll get to see Mark's demo today if you stick around. You get to see Mark show that in action, and I also do a deep dive down into how we handle network and the benefits of our architecture and whatnot. It's really cool. I think you'll dig it. It's a short demo too. Other interesting things that are coming out in either 4.0 or 4.1, we'll be launching a user file system. Now, this is really exciting. The Meadow F7 board actually has 32 megabytes of flash on there, and when you create a Meadow application, the application that you upload is usually very small, somewhere 4-6 megabytes or whatever. So you have a pile of space on that flash chip, and that's non-volatile storage. You can think of that as a hard drive. And so we're making that accessible, and we're also shipping some up-level APIs for managing that space, including giving you environment special folders where you can put your application data, like your database, which is coming, really cool. Also, like cache folders, so we'll automatically clear data in the cache on restart and whatnot. And the first thing that we're shipping with that to take advantage of it is SQLite, and this is going to be just so awesome. I'm really excited about this for my own projects. For the Beehive you saw earlier, I want to log data, and I want to log data in a modern way. I don't want to just try to throw it into a file and then append to the file and like have to parse that. No, I want to put it in a database. So we're going to be shipping SQLite and also SQLite ORM support with help from Frank Kruger, and that means that you'll have first-class database logging, non-volatile storage, and you'll be able to do it in a modern way. You'll simply be able to new up some objects and save the objects there, and then you can batch all your data up and then send it up to the cloud via the network stack. So I'm really, really excited about Beta 4.0. Other major features in the 4.0 series, or in the 4 series that are coming down the pipe, .NET Core 3.1. So this support's actually done. It's a matter of doing some final testing on that, and along with that, we unlock Visual Studio VS Code support. So VS Code requires .NET Core for its build plugins and whatnot. So I'm really excited to unlock VS Code. Also Bluetooth. So Bluetooth uses all the same comms and plumbing as the network stack. And so now with the network stack being effectively done, it's really just a matter of wiring up our Bluetooth API. And so that's actually coming soon too. We have just a tremendous amount of velocity right now, and everything is sort of coming in at once. And so really it's a matter of like, picking the right things, really testing, validating, and then getting them into a stable release. Other things that are happening in this front also mono runtime and garbage collector, so memory stabilization, and really optimization for microcontrollers. And so these are some hard problems that we've been working on there to really make this work in a microcontroller and really be stable there. Additionally, power and sleep APIs. So those are largely drafted. It's just a matter of wiring them up. And then, of course, AOT, which I talked about earlier. So that's still coming down the pipeline. Already works, proof of concept. There's some opportunities to fix the little dark corners of the implementation of that and whatnot. And then finally, debugging is also very, very close. We actually have it working end to end. The only thing that we're waiting for now is to wire it up into the IDE. In fact, in our internal builds, you can actually use the mono debugger over console. So this is an interesting place where maybe someone from the community can actually work on this as well. If we've had other folks that have worked on the IDE integration, like our Linux support came from Stuart. So this is actually a place to dig in and have some fun with us. So if we look at the roadmap now, we talked about all those features, looking at that from a date perspective, we're looking at, as I mentioned, Beta 3.1.1, Beta 3.11 should be shipping today. Worst case is comes out on Sunday, but I think we'll get it out today. Beta 4.0, the Wi-Fi network stack. So that comes out June 14th. June 14th, less than 3 weeks away. That's the day we're aiming to get everything out to you. And then, of course, I mentioned, some of this is a little bit fungible. What release .NET Core comes into and VS Code, and then of course the file system and SQLite. So those might fall into 4.0 or they might fall into 4.1, but they're happening July time, June-July time frame. Later on the summer, we'll be releasing a debugging support and Bluetooth. And there's some other things in here as well, by the way. This is kind of like broad strokes, but there are lots of little other features that'll come along in here. Fall, we think that the SMT module will be ready for integration into designs. And then later this year, probably power over Ethernet. And then next year, we'll be looking at early next year, Meadow Cloud Beta along with OTA updates, and then later on will be LTE support. So with all this said, I want to again say thank you for your support. Our customers, the folks that have been early adopters of Meadow have been really fantastic, and we really, really appreciate you and appreciate that you're here today watching this and joining us for DevCamp 2020. I really hope that you enjoy it. We've got a lot of really interesting stuff up ahead. I know that you have probably piles of questions, so think about them and write them down and email them to us. We're going to have a fireside chat with Karina and I tonight at 4 p.m. So that's a time to sit down and go through those questions. So really think about them and send them off. All right. Well, again, welcome to DevCamp. I hope you have a blast. The next thing that's coming up is Adrian is going to run us through an introduction and getting started to Meadow OS and Meadow Foundation. So he's going to, like I said, if you have a hack kit, if you have a dev kit, he's going to walk through getting that set up and get you oriented and understanding, what Meadow is, what Meadow OS is, and getting that up and running. So without further ado, I am going to hand it off to the great and awesome Adrian. So folks, thank you very much, and we'll see you soon.